Hello, we will chat about how to use Apache SystemML in Data Science Experience, DSX. You are watching IBM GitHub repository where this code and set of instructions have been posted. Here we are looking at README file which shows all the instructions. It includes a Jupyter notebook, DSX, and Apache SystemML. Component included as a part of this demonstration is a Bluemix Spark as well as a DSX. Technology we use a Jupyter notebook and Apache SystemML here. What is Apache SystemML? Apache SystemML is a machine learning tool which provides multiple options to data scientists to do machine learning. It contains set of out-of-box algorithms which data scientists can use it as it is or customize them per their need, or write a new algorithm using declarative machine language which has R or Python-like syntax. When data scientist writes an algorithm to run using SystemML, he or she does not need to worry about runtime environment or data size. SystemML has inbuilt optimizer which will generate a runtime plan based on data characteristics and runtime environment. So we have this notebook to demonstrate how to use the SystemML. Before going to that notebook, we have to do a couple of things. Like if you don't have account, you have to go to data science experience like datascience.ibm.com and sign up or log in, and then create a notebook. Let me go to the datascience.ibm.com. Okay, I already log in. So let me create a project. Say SystemML demo, optional description, demonstration of usage. Select Spark service. You can have default service or you can create a new service instance through Bluemix. I use object storage for a data to store the data, and I will say create. Once you have project SystemML demo, you add the notebook, create the notebook by adding the existing notebook. Here, if you look at the instructions, I have this link provided here. You can use that link, and you can use from URL option. First, you have to type the name, SystemML demo notebook. Put the link. Use the service. It's the same service what you use when creating the project, and then click on create notebook. As you can see, all the cells, when we stored this notebook, all cells were run for convenient purpose. First cell basically shows which version of SystemML. At this point, it is 0.14, but while we're recording this video, 0.15 is about to be released or released. Okay, so what this notebook contains, it shows some linear algebra operations like matrix multiplications. Then it shows some different flavors of linear regression. One of them is out-of-box algorithm from SystemML shapes, and others are basically customization or use the different flavors by customizing your new algorithm or new scripts you write yourself. Last but not least is basically shows how you can use SystemML similar to how you may be familiar with the scikit-learn. So similar interface has been provided here. So when you talk about machine learning, it's mainly compute-intensive operation is a linear algebra, and linear algebra is a matrix scalar operations. That's what it's a first example. Here you see X has been initialized, and then A has been computed here using transpose of X into X, and then sum of all cells has been computed. This is a script which is passed to the DML object with input parameters and expected output. You execute the script and then you get the result and print it. Cannot be more simple than this. But this is just example. If you want to see what are the additional operations, how to do additional additional functionality, etc., we have language reference guide. Toward the end of this demo, I will just walk through it quickly so that you know what else you can do through this one, through SystemML. Next topic is you can do linear regression. We have linear regression out of box the SystemML provides. Let's walk through it. And I can go through even different flavors of linear regression by customizing the scripts we can write here. So this is a data set, example data set coming from scikit-learn diabetes data set. I'm going to use the same data set throughout this notebook. You can see here data set has been retrieved and then data set has been split into train and test with a naive approach. If you're data scientist, you know what are the pros and cons and what is the effective way to avoid the skewing, etc., to get the data set properly split it. You get the data set and then as out of box, this is a linear regression DS, direct solve algorithm is there. You pass that as a DML script to the program with the input parameter, features, labels, input parameters, and expected output. You execute it and you get the beta and bias. Basically, you get the weight of the model and display the result. Now you can visualize this data to scatter plot, pie plot. I'm using it here. You can see black points are the training points and reds are the test points. Test points, and the blue line is basically the model which you can use to predict any new data. Based on new data points, you can predict the output. So this is the out-of-box algorithm. You can write your algorithm similarly using the script. Again, same data set. Here, if you look at the script, it's a small script similar to what we have in our algorithm. You get the X and then you do compute A and B and use the W to solve based on A and B and get the results, bias and weight. Pass the string to the DML input. The script is basically the input string with the X and Y and get the output. And then you similarly display the result or visualize the result. You see the similar result. There is another flavor, batch gradient. Now you see the scripts we have developed here. Similarly, for batch gradient, we can twist it a little bit and create another flavor of this one. Here, what we do is start with initial point and then compute a gradient on that weight, compute a stepwise alpha, and then compute new weight based by adding alpha into gradient, and that you do iteratively until it converges. Let's look at the script. It's similar to what we have earlier, except that now we are computing DW and alpha to compute a W, but instead of converge, we are putting restriction for maximization just for sake of this demonstration. And once you run the script, you get the output similarly to what we saw in previous example. Another example, you'll see the linear regression with conjugate gradient. Here again, you initialize the point, compute the gradient, compute the stepwise alpha, then you compute the next direction P by enforcing conjugacy with the previous direction, and then update the W. Again, script is here, similar to what we had earlier. We do all this computation, and then use the script to the DML input and get the output. What is the purpose of showing all these three flavors? Basically, data scientists can easily go and twist the scripts per their need, and which script to use, which flavor to use is up to data scientists, depends upon the data characteristics as well as objective they may have in their mind. So you can easily twist. You don't need to write 1,000 lines of code, but with a small, concise program, you can write it easily and get your desired output. Okay, so these are the different flavors. Linear regression is just one example. You can have similar thing. You can do it for all other algorithms we have already provided this one, or you can write your own algorithm as well, similar to the last 2-3 example I shown here. One more thing is how you can access this algorithm in different approach. Like many data scientists are familiar with the scikit-learn, where data scientists initialize one of the algorithm and then pass the input parameter like label, features, and parameters, and then they do fit for training, predict to get result, predicted result. Similarly, here you can see again same data set. You can see linear regression has been initialized. It is from SystemML, and then call fit and predict method to go to training and prediction the data. This is not what, but we have a lot more than this. I cannot cover in this small short of duration, but let's go through the documentation quickly. It's systemlapache.org. You can go here, you can download the documents, or you can click on get started, and you can see how you can install SystemML. If you want to use other than DSX, you can click on this one and see various options. You can configure, download the code, configure SystemML in your environment to start using it. There are tutorials, there are sample notebooks provided here. You can use it for your reference. There are in fact more tutorials, more notebooks available here on the GitHub repository. You can go to the SystemML samples and you can look at the Jupyter and Zeppelin. There are additional notebooks also provided here. And that GitHub repository link is here, source code. Okay, so in the documentation, go to the click on docs, go to the latest, and you can see there are various ways you can interface. One of the way I shown was the DSX, but there are additional ways, like you can use a Spark ML context, you can use a Scala REPL, you can use a Spark badge, basically Spark submit, or PySpark, Hadoop badge, JMLC, basically Java interface to interact with SystemML. So DSX is one of the easiest way. You don't need to do any configure. You can just quickly go through it and write the code the similarly way I shown here. So this is for the interface, interact with the SystemML. There is a language guide. If you are starting write your own algorithms, you have different options available, and the options and language reference are provided here. I shown an example of linear regression where there are a lot more algorithms provided here, and you can go through here and see what additional algorithms you can use it from here. Okay. Okay, if you're interested, you can click on development mailing list, where you can get updates on the whatever on the dev list. As well as if you're interested, you are more than welcome to contribute to Apache SystemML. That's all I have for today. Thank you very much for your attention. Thanks.